All right, this is the second recording for the cardiorespiratory endurance concept map. I'm going to go a little bit faster this time because the first few slides here are review. So remember that at the top of your concept map, you've got cardiorespiratory endurance training, okay? And at the bottom of your concept map, you have an increase in VO2 max, okay? And so when we train, our VO2 max goes up. Okay, and what you need to do is you need to connect all the training adaptations to the increase in VO2 max. According to Fick, VO2 is related to cardiac output and AVO2 difference. Therefore, VO2 max is related to cardiac output max and AVO2 difference. So with training, cardiac output max goes up because both AVO2 difference max and cardiac output max go up, okay? We already established that heart rate max doesn't change with training, but stroke volume max does, okay? And this is where we're going to focus in on this map. We're going to talk about this later, right? So increase in VO2 max due to an increase in cardiac output max due to an increase in stroke volume max. So we're going to build up from stroke volume. Okay. Remember that from Chapter 8 and your stroke volume concept map, that stroke volume is determined by three factors. We've got preload and diastolic volume, which is the primary factor, left ventricular contractility, and afterload or aortic pressure. Okay. Remember that if you increase EDV, you increase preload, and if you increase preload through stronger recoil and a better length-tension relationship, we get greater left ventricular contraction strength. Okay? And with greater left ventricular contraction strength, we're going to have greater left ventricular pressure, and that pressure is P1 when the left ventricle is emptying its blood into the aorta. Okay. Greater left ventricular pressure means that we're going to have a greater pressure gradient between the left ventricle and the aorta, which is P1 minus P2. Okay. So P1 is higher, then the gradient is higher. And if the pressure gradient is higher, we get greater stroke volume. Okay, so that's number one. Number two is left ventricular contractility. If we have greater left ventricular contractility, that also causes an increase in left ventricular contraction strength, and therefore more pressure, greater P1, bigger pressure gradient, bigger stroke volume. Okay. And the third one is afterload aortic pressure. So what we see with exercise is that if afterload aortic pressure goes down, okay, and this is essentially P2, then this pressure gradient also goes up, okay, because if P2 goes down, then the gradient goes up. Okay. So with a decrease in afterload and aortic pressure, we get a bigger pressure gradient, and then again, greater stroke volume. Okay. So keep in mind the factors that affect stroke volume, because any training adaptation that increases VO2 max through cardiac output and stroke volume must occur through one of these three factors. So the factors that we will talk about that contribute to an increase in stroke volume with training are left ventricular hypertrophy, left ventricular internal diameter, pulmonary ventilation, and total blood volume. Okay. We're going to talk about these on the next recording. Let's talk now about LVH and LVID. So LVH is left ventricular hypertrophy. The heart is a muscle, which can hypertrophy just like any other muscle in the body, like our skeletal muscles, I should say. And when a muscle hypertrophies, it gets thicker. Okay, so when you train the heart through exercise training, you force the heart to do overload, extra work, repeatedly, and this is going to cause the left ventricle in particular to hypertrophy because it is the ventricle that's doing the greatest amount of work. Okay. And what we see happens is when we get LVH, this increases left ventricular contractility. Okay. Stronger muscle, a thicker muscle is a stronger muscle and has a greater ability to contract. So greater contractility increases left ventricular contraction strength. Okay. So be careful not to confuse contractility and contraction strength. Okay. Other things can affect contraction strength. Okay. Preload can affect contraction strength. But the effect of preload on contraction strength is completely independent of contractility. Okay? So assuming that there was no change in preload or afterload, if contraction strength went up, okay, it was because of contractility. And you know the rest of the story. With a greater left ventricular contraction strength, we get greater left ventricular pressure, which is P1, greater pressure gradient between the left ventricle and the aorta, P1 minus P2, and greater stroke volume. Okay? So one of the 11 factors that comes off the top of your concept map is going to be LVH. Okay? Another one is going to be called left ventricular internal diameter. Okay? And this is the left ventricular chamber size. So hypertrophy basically looks like this. Okay, the walls get thicker. Okay. And chamber size means the opening on the inside also gets bigger. Okay, so not only do the walls get thicker, but the volume, the inner volume of the left ventricle increases with training. Okay, and we call that an increase in LVID. An increase in LVID increases the ability of the left ventricle to fill. Okay? And if a left ventricle fills more, that means you're going to get more EDV. Okay? If you get more EDV, you get more preload. And if you get more preload, you get greater contraction strength, greater left ventricular pressure, bigger pressure gradient, more stroke volume. Okay? So another one of the 11 factors coming off the top of your map is LVID.